circular motion, so you're finding r plane, or the distance between two cities on Earth. You'll be looking for angular velocity, linear velocity, and sector area. So four equations that you're going to be looking at are S equals r times theta. S is always distance, so it's S equals r theta. And this is when you know theta and you know your radius. So when I know my radius is a certain distance length, and I know my degrees, and remember theta will always be in radians, so if I give you degrees, you need to change it to radians. So usually with this, the first thing you're going to do is change the radians. Okay. Once that's done, I multiply r and theta. So I go r times theta, and you're done. So you have your distance. And you want to make sure that you're always answering it with at least, I'll probably tell you 4 significant digits, maybe I'll tell you 5 significant digits, and include a label. If it's on the Earth's surface, we're going to use 6,400 kilometers or 6,400 every time. It's not listed. Please write that on a note card if you need to. If I'm asking you to find the height of how far something's been lifted, if I give you r, and I'll tell you it's had 2 rotations. Okay, here we go, you've got your theta, you've got your r, you're going to use s. So this is for distance, height. So that's always going to be s is the same as distance, height, and length. If you're looking for theta and you know radius and height, or radius and distance, we're going to just manipulate it and say theta is s divided by r. And we do that by what's called a literal equation. All we do is we solve the equation for theta. So use this when you're looking for theta. That means I know what my s is and I know what r is. Always write down the variables that you're given, and that helps you when you're inputting everything into an equation. Next, we've got sector area. So area, usually I'm going to give you a problem where you're finding the arc length or the distance on the surface, a curved surface, and then I'll ask you to follow it up by, okay, what's the area of that sector? So area, in this case, is going to be 1/2 of s times r. Okay, unless I give you theta and a radius, then you're going to use this one. Okay. So we're going to use one of the two. I actually prefer this one. It makes more sense to me to have you build to finding an answer. So what's the length of a track, the curve on a track? If we decide to fill it all with gravel, what's the area that we covered? That's what that looks like. So arc length, I use S because it makes sense. This goes along with physics. 1/2 SR, or 1/2 theta r squared. That is area and distance. The other one is angular velocity. Angular velocity is omega or the W. I can find it in several ways. One way is if I know theta and I know time, I can find my angular velocity. What we usually do in math or even out there in the real world, they're going to talk about rotations per minute or cycles per second. So if you know what your cycle is or your rotation, you're going to just multiply by 2pi, because we have to think of it this way. Like if I had a tire on pavement and after 2 rotations or 1 rotation, how far did it go? Well, 1 rotation with your tire is 360 degrees, or it's 2pi. Everything we do is in radians, so we need to multiply RPMs by radians or your cycles. So also, I can say W is rotations per minute or second times 2pi. So 2 ways to find it. This is the way I normally go, is I'll give you rotations per unit time, and just find your, find omega, 5.5. Then I'll follow it up with, okay, if the radius is like 0.17, or if the radius of the pulley is 2 meters, or if it's the Ferris wheel, okay, how far have you moved, right? So, if I'm looking for that, or I'm sorry, how fast are you going? That's linear velocity, v, and v is the same as w times the radius, because it's distance over time. If you're going to take physics with Mr. Doty, or if you are in physics, you may be talking about dr over t to get velocity of something that's circular. Usually d divided by t is your velocity. And so these are your equations that you're going to be using. So you've got this one. Okay. And we manipulate it this way. So you've got 1, 2, 3, 4, 5. And you've got 6 equations. And of the ones that you're going to be using on Monday, this one, because it'll be a follow-up with this, S equals R theta. Also, theta equals S divided by R. And theta is omega divided, omega is theta over time. So let's, if I give you a problem where the Earth has turned, after 4 hours, you know, its angle is, let's see, we're 1/6 after 4 hours, 1/6 of the way around, it'd be 60 degrees. So I say the Earth turns 60 degrees in 4 hours. What is its angular velocity? Or if I say Jupiter has a rotates once, has a day that's 9.9 hours, what's the velocity? Yeah, angular velocity at a 40-degree turn. So, and then how far has a spot on Jupiter moved? It's 22, or how far is the red storm? It's 2 degrees south of the equator on Jupiter. And, you know, what the radius of Jupiter is, you know, how far is it from the equator? Or I think Pluto has the heart, it might be on its, yeah, I'll give you a radius, and I'll give you degrees, and it's just like on Earth. In the same hemisphere, we subtract. Different hemispheres, we add. So you'll have something to do with a city on the Earth. You'll have something to do with a track, which means you're going to find area. You'll have something to do with a planet's orbit. You'll have something with a circular saw or a motor or a turbine. And you know, so some you're going to add and subtract depending on which ones I give you. You're guaranteed you have one to subtract, one to add for cities, or 2 things are placed on a planetary body. Find the area of a track or a sector of it. It might be there's a ground divided into 32 equal sections. So what's the area of one of those sectors? And finding a velocity. So RPMs to radians per unit time. Finding linear velocity. Remember, you'll be able to ask me questions on identified variables. Okay, and if you need assistance with which formula to use, always be okay. Just look for. I'm asking you for how fast is something moving. Velocity. Okay, what's the angular velocity? Okay. What's the area? Okay. Distant, height, or length. We're going to be using this formula. And if I'm asking you to find theta given, this is the length of an arc and this is the radius of a circle, this is what theta is. Okay. So I'm going to type everything out so you don't have to worry about my handwriting. And I will bold the face, any key words for you. And that was a suggestion from last year. So I hope this helps you out with getting ready for Monday's little exercise.
which will not take you 50 minutes, maybe a half hour. See you Monday. Thank you.